Hey guys, today we're looking at the HL component of section 2.2, aggregate demand and aggregate supply. This is all about the Keynesian multiplier, which we have seen briefly already in our work on the circular flow of income. I want you to actually stop now and draw the circular flow model. If you are unable to do this off the top of your head, then that means you don't understand it quite well enough and you will need to revise. Okay, so here is the circular flow model. We've got our leakages down here, savings, tax, imports and injections, investment, government spending, exports. We know already that there are four things we can do with household income. Consume it domestically, C. Save it, S. Be taxed, T. Or buy imports, M. There's nothing else we can do with it. For every dollar of income earned by households, a certain percentage is put towards each of the four uses. This percentage is called their marginal propensity. Marginal propensity to consume is the proportion of each additional dollar of income used for consumption. Marginal propensity to save is the proportion of each additional dollar of income that is saved. Marginal propensity to tax is the proportion of each additional dollar of income that is taxed. And marginal propensity to import is the proportion of each additional dollar of income that is spent on imports. These figures are given as decimals, and as there is no other destination for income, together they add up to 1. We are mostly concerned with MPC as this feeds back into the circular flow. We'll go through an example now to show how the Keynesian multiplier works. Let's assume that our friend, the Treasurer Scott Morrison, announces new government spending of $10 million in order to reward economic features. Great policy. Anyway, this $10 million is G, an injection. By knowing the marginal propensity to consume, we can see how much induced consumption there will be. With an MPC of 0.7, this means there will be induced consumption of $7 million. But this is not where it ends. This $7 million feeds back into the circular flow, and therefore 70% of it again is induced consumption. And this repeats, and repeats, and repeats. And then what we really want to know is the final impact of this initial $10 million injection. To work this out, we don't keep following this forever. We just use a simple equation. Keynesian multiplier. There are two ways of displaying it. So at the top here, we've got the simple way, 1 over 1 minus MPC. Or it can be 1 over MPS plus MPT plus MPM. It comes out to be exactly the same, but you do need to know both ways, as you may not always be given MPC in the question. Using the multiplier, we can ascertain the total effect of the injection into the economy. So here, expected change in real GDP equals the initial injection times the Keynesian multiplier. So for the example that we used, the expected change in real GDP equals $10 million, times 1 over 1 minus MPC, which equals 10 times 1 over 0.3, which equals 10 times 3.33. Which gives us a total expected change in real GDP of $33.33 million. Again, always remember to write the units. If you aren't given the MPC, of course, you could use MPS, MPT, and MPM to arrive at the exact same answer. Now let's take a quick look at how this looks on an ADAS diagram. As we're looking at the Keynesian multiplier, guess what? We're going to use the Keynesian ADAS model. The first increase in AD to AD1 is the initial injection of $10 million. AD2, however, is where AD will actually arrive, as this includes the initial injection of $10 million, plus the induced consumption of $23.33 million. So the total change in real GDP will always be a bit bigger than the initial injection. The Keynesian multiplier tells us how much bigger. So this really is the Keynesian multiplier. We'll go through some questions in class, but I think you will find it relatively straightforward.